Welcome back to Virtual Space TV 3D. I am Amanda Bush. The past month has been an exciting time for space development. In the previous show we reported on the launch by Orbital Sciences of the Cygnus Cargo Module on the Antares rocket. The Cygnus spacecraft subsequently performed well as it approached the International Space Station. However, the berthing on September 22 was delayed due to a small software glitch. The berthing could have occurred a couple of days later, but a Soyuz with 3 new crew members was arriving, and so the decision was made to delay the next berthing attempt for a week. On Sunday morning of September 29, the Cygnus spacecraft made its second rendezvous with the station and approached it carefully without any problem. U.S. astronaut Karen Nyberg and Italian astronaut Luca Parmitano guided the vehicle in close to the station and then grappled it with the station's robotic arm. With the arm, the Cygnus was brought up to the docking port and berthed to the station. Later that day, the hatch to the module was opened. The vehicle was unloaded over the following weeks and then loaded up with trash and unneeded equipment. On October 22, the Cygnus has unberthed from the station and later that day burn up in the atmosphere over the ocean. This will mark the conclusion of NASA's very successful Commercial Orbital Transportation Services program, which combined agency funds and private investment to develop the Antares rocket and Cygnus module, and also the SpaceX Falcon 9 rocket and Dragon capsule. Cargo delivery will now proceed with the 2 systems. The cost to NASA for all of those capabilities was just $700 million, less than half the cost of a single space shuttle mission. On the same day that the Cygnus capsule berthed with the ISS, SpaceX launched its upgraded Falcon 9 rocket for the first time. It is called the Falcon 9 version 1.1, but it has so many changes it is really a brand new rocket. For example, it is 16 meters longer, which allows for more propellants. The numeral and 1D engines add considerably more thrust, and they are arranged in a circle on the base with one engine in the middle rather than in a tic-tac-toe pattern. The payload capability has increased by almost 50%. The unusually long and thin rocket lifted off from the company's new launch facility at the Vandenberg Air Force Base in Southern California. The Canadian Cassiope satellite was placed successfully into a polar orbit, and several secondary satellites were also released into orbit. 2 additional tests were carried out as well. One of these was an attempt to refire the upper stage engine, but it was aborted. The company said they understand the problem and believe it is easily solved. It needs to be fixed before their next launch because the upper stage will need to refire its engine to put a communications satellite into geostationary orbit. The other test was of a controlled return of the first stage booster after it separated from the upper stage. SpaceX wanted to bring the booster down for a soft landing on the sea surface as a test of their plan to eventually fly boosters back to the pad and reuse them for future flights. The 3 engines of the booster fired and successfully slowed it and brought it down near the water. A single engine was to land the booster just like the Grasshopper test vehicle has done in Texas. However, the vehicle was spinning, and this led to depletion of fuel from the engine, causing it to stop firing, and the vehicle fell into the water. Nevertheless, the company hailed the test as an overall big step forward. The successful braking of the vehicle from its hypersonic speed at stage separation means that the hardest aspect of the flyback and recovery of the booster has now been proven. Speaking of the Grasshopper, on October 7 the prototype reusable first stage booster made its highest flight ever. It flew vertically for 744 meters and then came down for a safe landing. This Grasshopper will now be retired. A new upgraded Grasshopper that is more similar to the boosters that will be used on the actual Falcon 9 version 1.1 will soon begin its tests. It will do low-altitude tests in the same SpaceX facility in Texas and then be moved to Spaceport America in New Mexico, where it can go to much higher altitudes. SpaceX believes from what they are learning from the Grasshopper vehicles and from the first stage return tests on Falcon 9 flights, They will be able to fly a first-stage booster back to the pad in 2014 and reuse the booster. The booster represents 75% of the cost of a launch, so reusing it even just a few times will greatly reduce the cost of getting payloads to orbit. Two probes from two different countries will soon be heading for Mars. India will launch its first spacecraft to the Red Planet. A polar satellite launch vehicle will send the Mars Orbiter mission probe on a 300-day flight. The spacecraft carries a camera, a methane sensor, and several other instruments to study the Martian surface and atmosphere. Unfortunately, the initial launch date of October 28 has been delayed recently and a new date will be announced soon. In the US, the Mars Atmosphere and Volatile Evolution Mission, or MAVEN, is set to take off on November 18 on an Atlas V rocket. When the probe reaches Mars orbit 10 months later, it will begin its study of the upper atmosphere. The goal of the mission is to understand the role that the loss of atmospheric gas to space played in changing the Martian climate through time. It will investigate the question, where do the atmosphere and the water go? Now let's have a look at the official NASA video explaining the next Mars mission in more detail.
We've never sent a spacecraft to Mars just to explore its upper atmosphere. If you imagine Mars as having had a thicker, warmer atmosphere early in its history, where did the atmosphere go? Where did the water go? And there are only two places it can go. The atmosphere can go down, or it can go up and be lost to space. MAVEN is the Mars Atmosphere and Volatile Evolution mission. We're trying to understand basically why the climate changed on Mars, why Mars appears to have gone from an environment that was habitable to microorganisms at least, to one that is the cold, dry, uninhabitable environment we see today. By looking at the nature of the upper atmosphere today and how gases can be lost out of the atmosphere to space today, we learn about the processes that control the atmosphere, and we're going to have a good understanding of what the history of the atmosphere has been.
Thanks for watching this episode of Virtual Space TV 3D. Please return for our next report on the latest developments in spaceflight and space science. I'm Amanda Bush saying goodbye for now.